We have a question that requires a little bit of graphing and some formulas of a tangent, which is y equals mx plus c to a curve. So let's have a look at what the function is. Initially, we've got a past paper question. It is from 2012. It's paper 2, so you can use your calculator. And we've got this function here, 1 over 2x minus 4 plus 3. Now, the curve which was drawn here has a negative gradient, and there is a particular point in part C. It says if PQ is any point on that function, and I've put that function here, show that the equation of the tangent to that function can be written as. Now, what we've got here, we had the derivative, which was let's just look at this again. 2x minus 4 to the negative 1 plus 3. So the derivative is negative 1, 2x minus 4 to the power of negative 2 times by 2 plus 0. The derivative of 3 is plus 0. So we've got negative 2 over 2x minus 4 squared. That's the derivative. Now there is a function, and the tangent to that curve at PQ. So when x equals P, the gradient at that value will be negative 2 over 2P minus 4 squared. That's the gradient. Now, the equation of a tangent is y minus y1 equals mx minus x1. That's one form of a equation of a tangent. It is from y minus y1 over x minus x1 equals the gradient, which is y2 minus y1 over x2 minus x1. Now, of course, you could use y equals mx plus c. However, I'm going straight for this particular form, which is called point gradient form. If you know the gradient and you know an xy point on the tangent. So let's substitute y1. We're talking about q equals m. So that's negative 2 over 2p minus 4 squared. X minus and x1 is p. Now, the thing is, q over here, we've got, if we find q, the function of q in our function here, we've got too many variables here. We've got a q and we've got a p, and we've got a p. In our formula, we've got a p, but no q's. So if we substitute the function of p will equal q. So if we put p into this equation, therefore the function of substitute p into there, we should get 2p minus 4 plus 3. So that's what q equals. Q equals 1 over 2p minus 4 plus 3 if we substitute in the function. Right, so you substitute pq, works in the function, and we used the derivative to get the gradient of our tangent, which is this value here. That's the gradient of the tangent, 2p minus 4 squared. I'm going to replace q with this value in terms of p. So we've got 1 over 2p minus 4 plus 3. So that's what I'm going to replace q with. So everything else is still y minus q. Now I've got to remember that's Q, equals -2, 2p minus 4 squared, x minus p. Notice there's no denominators up here. So to cancel our denominators, if I multiply everything by 2p minus 4 squared, let's put, see that y minus 3? Can you see y minus 3 there? I'm going to put y minus 3 here. And then I'm going to, that's a minus that, that's a minus that. Remember that, minus 1 over, just adjusted this slightly. So we're looking closer to what we want. 2p minus 4 squared. Now if I multiply this, and this by 2p minus 4 squared, I will get, I'll come up here and I think I can, yeah, move that to the side. I will get y minus 3, multiply that by 2p minus 4 squared, minus, so I'm going to multiply that by 2p minus 4 squared. I'm going to multiply that by 2p minus 4 squared, and I'm going to multiply that by 2p minus 4 squared. You see, that will cancel here, and one of those will cancel there. So that's going to be left with minus 2p, that's minus 2p, and minus -4 becomes plus 4, equals, and we're left with, I'll expand that, -2x plus 2p. Now this is good because this is on the left-hand side. We've already got that. If I leave this on the left-hand side, we've got our left-hand side the way we want it. Put everything over here. We've got minus 2x plus 2p plus 2p minus 4. And then tidy this up, you'll see where the 4p comes from. And we've got, I'll just put it in the order of our question. I'll just change this around. It's just commutative. And we've got a -2x plus 4p minus 4. And that's what we wanted to end up with. All right, so that's what we wanted to end up with. And that's what we've got. Ooh, bit of algebra. Hope that helps.